Great. We do have a full agenda today, so just in the interest of time, I'll go ahead and get started as folks, looks like folks are still joining, but let's go ahead and get started. So good afternoon, everyone, and welcome to the first of a three-part Integrated Food Safety Centers of Excellence webinar series focusing on food safety in correctional facilities. My name is Amanda Tran, and I am with the Colorado Integrated Food Safety Center of Excellence, or the COE for short. We are one of 5 food safety COEs across the country with the mission of providing peer assistance, resources, and trainings to support state and local health departments build their capacity to track and investigate enteric diseases. And the topic of today's webinar is unique outbreaks and exposures in correction settings. We have 4 subject matter experts joining us today from Arizona, Colorado, and California, and they'll be sharing their outbreak experiences. But before we get started, I'd like to briefly go over a few housekeeping items. This is the Zoom meeting is set up in a webinar mode, as you might have noticed, and you only be able to see and hear presenters. And if you have any questions for our presenters, please go ahead and add them in the Q&A feature at the very bottom of your Zoom window or in the chat box, and we'll answer as many as we can there or at the end of the webinar during our Q&A session. And please go ahead and use the chat box now to share where you're joining us from this afternoon. If you're experiencing any technical difficulties, if you can't hear me or have any audio video difficulties, please go ahead and send a message to all panelists for assistance. And we do have live transcription available, which can be turned on and off using the show captions button on the toolbar of your Zoom window. And lastly, if you're not able to stay for an entire webinar, or if you would like to rewatch it, recording will be available in a few days on the same webpage that you used to register. So now that all the technical details are out of the way, let's go ahead and get to the presentations. I am pleased to introduce our first presenter, Dr. Jolie Weiss. Dr. Jolie Weiss is the Office Chief for Infectious Disease Control at the Arizona Department of Health Services. And Dr. Weiss received her PhD in epidemiology and community health from University at Buffalo. She joined the ADHS in 2007 as a foodborne disease epidemiologist and served as outbreak capacity and preparedness epidemiologist. And during her tenure at ADHS, Dr. Weiss has also served as a program manager for the Food Waterborne Disease Program. And with that, I'll hand it over to you, Jolie.
Great, thank you very much. Can you all hear me?
Yes, we can hear you.
Okay, perfect. Thank you very much. All right, well, thank you so much for that introduction and inviting me to present today on a botulism outbreak in an Arizona prison that we investigated back in 2012. So first, a little prelude. In August of 2012, 4 inmates in a maximum security prison in Arizona, Prison A, were diagnosed with botulism. Although there was no laboratory confirmation, Pruno, or prison brewed alcohol, was a suspected source. So now moving forward to the morning of November 24th. Health department officials were notified of 2 inmates in the same facility, Prison A, who had developed signs and symptoms of vomiting, dizziness, blurred vision, double vision, dry, difficulty speaking, shortness of breath, and bilateral symmetric ptosis, or drooping eyelids. And due to the botulism outbreak in the same facility only 4 months earlier, botulism was immediately suspected. On the same day in the afternoon, 2 more inmates were hospitalized with similar signs and symptoms. Then early the next morning, an additional 3 inmates were hospitalized. Then on November 26th, an 8th inmate was admitted to the hospital. 7 of the 8 patients were intubated and put on mechanical ventilation shortly after admission to the hospital due to respiratory failure and a rapidly progressive descending paralysis. And botulinum antitoxin was administered to all 8 patients. So let's take a quick step back and look at the causative agent. So botulism is caused by a toxin made by Clostridium botulinum, which is a gram-positive obligate anaerobic bacterium. This bacteria is found in soil worldwide and is a spore-forming rod. This bacteria usually exists as a dormant spore in the environment. The spore in itself does not cause disease, but can be heat resistant up to high temperatures. While the spores are mostly harmless, in certain conditions, these spores germinate into vegetative or actively growing cells. As the vegetative cells grow, they also produce the neurotoxin that causes botulism. And very specific conditions are required for this to occur. So this includes an anaerobic environment with low salt, low sugar, and low acid, as well as a warm environment. And there are 7 types of botulinum toxin, types A through G. And types A is the most common form in the US, and this was the type associated with this outbreak. So now back to the outbreak. To learn more about the cases, we visited Prison A and interviewed correctional officers and inmates. We also sent specimens from patients and potential sources to CDC for testing. Interviews with correctional officers revealed that inmates appeared to be intoxicated the day prior to symptom onset and presentation to the prison clinic. Additionally, on November 23rd, all patients reported sharing a batch of pruno that was made mostly from potatoes. And a sample of pruno was found in the hallway near the area where the ill inmates were housed. So pruno is made with a variety of ingredients, but commonly includes potato, fruit, sugar, and or bread products. These materials are sealed in a plastic bag or bottle for fermentation and create a strong, distinctive odor. Product is often warmed using body parts and often hidden in toilets. Inmates reported consuming pruno on a regular basis or as often as they're able to collect the needed ingredients, and especially around the holidays. And this consumption was around the Thanksgiving holiday. Potato-based pruno has previously been associated with botulism outbreaks in correctional facilities. And potatoes and other root vegetables may serve as a particular risk for botulism, as the bacterial spores can remain on the skins from the soil. And the fermentation process, particularly with certain ingredients like the potatoes, can create the ideal environment for bacterial toxin production. So 6 patients were housed in one pod and 2 were housed in a completely separate pod. So one question we had was how inmates in 2 different pods, separated by a solid concrete wall, could have shared the alcohol. Inmates in this prison are confined to cells for 24 hours a day, 4 days a week. Showers and 2-hour periods of recreation in an enclosed outdoor recreation area do occur 3 times a week. Inmates do not have contact with other prisoners besides their cellmate, and all meals are consumed inside the inmate's cell. We did find that inmates from both pods went to the recreation area at the same time. However, the recreation areas had covered roofs and solid concrete walls separating the pods, as seen in this picture. Interviews with inmates and correctional officers resulted in 3 hypotheses for how pruno could have been shared within the pods and between the pods. So first, an officer could have carried the pruno from one cell to another. Second, fishing is reportedly a common way of passing items from one cell to another. This involves sliding objects underneath cell doors to other cells. This could easily have occurred between cells within the same pod. But fishing items between pods A and pods B would be considerably more complicated and involve sending an item underneath a cell door, a pod door, bouncing it off the officer tower back through the other pod door and underneath another cell door. And while this seems improbable, we did learn from correctional officers and inmates that items are passed this way on a regular basis. However, our leading hypothesis is that Pruno was being shared between pods in that recreation area. And although there are concrete walls, there is a small grate at the ground level between these two areas, with holes approximately pencil size in diameter. And correctional officers discovered that inmates could take coaxial cables, which are available to the inmates through the prison commissary for televisions, and remove their inner wires and turn the cable into a long, flexible straw. And the cable fit perfectly into the top of the inmates' water bottles, as seen in the pictures here, as well as through the holes in the drainage grate between the two recreation areas. And this is how we believe the alcohol was shared between the two different pods. So Prison A did not enact any control measures after the first botulism outbreak in August. However, after the second outbreak, the prison was very proactive. Local public health officials were invited to provide education for correctional officers and inmate peer educators about the risk of botulism from potato-based pruno through in-person presentations and educational flyers. In addition, informational papers from the CDC websites and fact sheets for inmates from a previous outbreak were distributed through the prison and shown on the correctional facility television channel. The correctional facility also decided to limit access to potatoes, sugar, and fresh fruit to minimize the risk of botulism due to pruno production. And after the investigation, we worked with inmates, correctional officers, and public health officials to design bilingual educational flyers for incarcerated populations to teach about the risk of botulism from pruno, particularly pruno made from potatoes. And these flyers were distributed to correctional facilities across Arizona. However, there remains a shortage of information about this topic on the national scale, and more effort should be made to educate both correctional officers and inmates about these risks. Finally, we also conducted a knowledge, attitudes, and practice study. The goal of our investigation was to learn more about pruno consumption in correctional facilities, assess inmates' knowledge about the risk for botulism from pruno, and ascertain inmates' preferred health information routes for future education. Interviews were conducted by public health staff over unrecorded telephone lines in visitation areas, and no correctional officers were present. And just briefly, some of the main findings from that study were that convincing inmates to stop drinking pruno would be very challenging. Paper-based and in-house TV channels are an effective way to increase awareness, and that knowledge of botulism and pruno risks did improve after our educational campaign. And here I've included two manuscripts that came out from this investigation if you're interested in learning more. I can drop these in a little bit into the chat as well. And that's all I have this time. Thank you very much. And if there are any questions.
Thanks, Jolie. Very interesting presentation. And I Nicole earned a Bachelor of Science and a Master of Science and Public Health degree at the University of Colorado Health Sciences Center. She has been employed as an epidemiologist at the Colorado Department of Public Health and Environment's Communicable Disease Branch since 2002. And currently, Nicole serves as the Communicable Disease Branch Chief, and much of her work is focused on communicable disease response activities and programmatic and funding oversight. And then I will hand it over to you, Nicole.
Great. Thanks, Amanda. Hi, everyone. Today I'm going to talk to you about a Campylobacter outbreak that I was part of the investigation team to look into back in 2005. So this is an oldie, but a good outbreak to demonstrate just different types of outbreaks that can happen in prison settings and some unique features. So some quick background, I'm sure you're all familiar with Campylobacter jejuni. It causes diarrheal illness. It often can mimic appendicitis, and in some cases can be associated with more severe Guillain-Barré syndrome, which is more of a neuromuscular syndrome. It's the most common reported bacterial foodborne pathogen in Colorado as well as in the US. There are several animal reservoirs, including poultry, cattle, puppies, kittens, and other animals. You don't tend to see a lot of person-to-person transmission with Campylobacter because it's microaerophilic. It really thrives in a more reduced oxygen environment and doesn't survive too long on surfaces. So you don't tend to see too much person-to-person transmission, but it is possible. Reported outbreaks, at least in Colorado, are relatively rare compared to other enteric pathogens that we work with. And illness is associated when people have contact with or consume poultry or contaminated poultry. They consume raw and sometimes pasteurized milk, untreated water, direct animal contact, and cross-contamination. So way back in September of 2005, the Colorado Department of Corrections, or DOC, their medical director contacted CDPHE to report 2 cases of campylobacteriosis among incarcerated individuals, and these individuals resided at 2 different facilities. Additional incarcerated individuals were reporting gastrointestinal illness across different Colorado prisons. Back in 2005, the overall Department of Corrections census was slightly more than 13,000 incarcerated individuals housed at 24 different facilities across the state. There was a common food supply at all DOC facilities, as well as a common canteen or vending system for incarcerated individuals who had the means to purchase food. The Department of Corrections operated a dairy at one of the facilities that provided milk to all the facilities. They provided milk, about 3,000 gallons milk on each of 3 days per week, and that was distributed across the system. Back in August of 2005, the routine milk testing was normal, so there weren't any aberrations found in routine milk testing prior to this outbreak occurring. We did learn when the cases were reported to us that the system had started using a new frozen raw turkey product within their menus. And that was recently introduced to all facilities. And prior to that, they were using a pre-cooked product. So initially, our hypothesis might be that this new raw product might be the culprit causing this outbreak. So that was kind of on high alert for that, at least going into this. So a few just considerations when working any type of disease outbreak in a correctional setting. Obviously, you're working in a situation where people are living in close quarters as a congregate setting, so things might be more easily spread from person to person. There's not only need to be mindful of people who are incarcerated becoming ill, but staff members as well. Staff members may eat in the kitchen. They are certainly having contact and sharing space with incarcerated individuals. You need to be mindful of the movement of incarcerated individuals. There's a lot of movement between facilities. There's always people coming into a facility, and then people who have served their terms who are getting moved out of facilities or transferred to a different facility. So needing to be mindful if someone is sick, if they might be introducing a pathogen into a new facility they might be transferred to. There's different hygiene and disease control considerations, such as availability of soap and certain disinfectants that you might recommend in other settings may not be feasible to use in a correctional setting. Some facilities may have limited capacity to isolate ill people. They might just have limited cell space where people can be isolated if they're sick. There can be issues with contraband food, so foods that aren't supposed to be in the prison setting, as well as hooch, which is how our Department of Correction refers to pruno, which Jolie just mentioned in her prior presentation. A lot of incarcerated individuals have underlying health conditions that might make them more susceptible to certain pathogens or make them more susceptible to severe illness caused by an infection. Food is usually prepared by incarcerated individuals, so you need to be mindful of different training considerations. And if you have a gastrointestinal illness outbreak, be mindful if those incarcerated individuals might be preparing food for others where they could potentially contaminate it if they're sick. Access to medical care might be variable. Sometimes there are copays that facilities require. That might be a reason why an incarcerated individual may not want to seek care. Sometimes if you want to go in and do interviews, we've had success doing this here in Colorado, where we have been able to interview incarcerated people confidentially in like a room with having a prison staff member outside the door for safety concerns. But that's something generally we've had to work out with each prison prior to going in and doing interviews. Like all work that we do in communicable disease, be mindful of language and literacy levels, and just know that information can spread very quickly in a correctional setting, and getting ahead of that and having clear public health messaging can help to help kind of control the rumor mill. So in our outbreak, we set a case definition, counting cases as incarcerated individuals that had laboratory confirmed Campylobacter jejuni infection with onset anywhere from September 1st to October 1st of 2005. We were also counting probable cases, but we had quite a few people reporting illness, so we really focused our efforts on trying to find the cause of the outbreak by looking at lab confirmed cases. We did that by just doing routine lab-based surveillance at the facilities. We sent a bulletin to all Department of Correction facilities to alert them to the situation and recommend that they test suspected cases immediately. For one of the initially affected facility, which we'll call Facility A, we conducted a medical record review to look for retrospectively for potential cases. And then in Facility B, which is our largest prison in the state, as well as all other facilities, we had the prison health staff do cell-to-cell checks for illness. And then if anyone was reporting symptoms, recommended that they have a stool sample collected and be tested. We set up a case control study at Facility B. Again, Facility B was at the time and still is our prison with the largest population, and in this outbreak had the most identified confirmed cases. We did interview all Facility B cases, which ended up being 34. We did a matched case control study, so we found one control per case matched by prison unit, and the controls were randomly selected from rosters by prison staff. And those controls were excluded if they reported any gastrointestinal illness during our timeframe of interest. We had a very long questionnaire, which included all items on the prison menu, and the case and their paired or matched control were asked about foods eaten during the 2 to 5 days prior to the case's onset. We also asked about canteen and vending items, as well as hooch and other illicit foods that may not necessarily have been on the canteen menu or the prison menu. So here is our epi curve from this outbreak. In the end, we had confirmed cases found at 4 different facilities, with the bulk of them being at Facility B, which is again the largest facility. And you can see that the onset dates covered several incubation periods for Campylobacter. So this was likely a situation where whatever the culprit was causing was contaminated for a longer period of time. Among our 40 cases, the median age is 35 years with a range of 20 to 65 years. All males were affected here. We didn't have any females affected in any of our prisons, or the female prison, or the prison that typically houses females. We had one case that was hospitalized and was diagnosed with appendicitis, and fortunately we had no deaths. The median duration of illness was 7 days, but ranged from 1 to 22 days. And the symptom profile was really consistent with what we typically see with Campylobacter infection. So in the end, while we interviewed all our cases, we were only able to get 31 matched controls. So we included 31 cases and 31 controls in our case control study analysis. And how it ended up is that cases were 16 times more likely than controls to have consumed milk, and 8 times more likely than controls to have consumed foods made with milk in the prison setting. 94% of our cases recalled drinking milk compared to 50% of controls. And interestingly, no cases who drank milk in half-pint containers became ill. Cases who drank milk from 5-gallon bags became ill. So as I mentioned earlier, the prison system at this time had a centralized dairy, and the containers of milk that would come out from the dairy and be distributed across the prison system included these half-pint containers that were really just individual servings, and then these 5-gallon bags that were in like a milk dispenser system. So it was really the 5-gallon bags that people who were becoming ill were reported drinking. Our hypothesis about the change in the turkey product did not pan out. That was not statistically significant, nor was consumption of fresh fruit. We were able to do a dose response calculation with our study, and compared to controls, cases are 7 times more likely to have had 1 or 2 servings of milk, 21 times more likely to have 3 servings of milk, and 22 times more likely to have 4 or more servings of milk. So really, the more milk people were drinking, the higher chance that they were going to become a case, and this was statistically significant. So this outbreak occurred back when we were doing post-field gel electrophoresis. We had not yet made the transition to whole genome sequencing, but we had the Campylobacter isolates from the testing lab sent to our state lab, where they were underwent confirmation to ensure that they were Campylobacter. And then once we had those isolates, PFGE was performed. There were 4 different PFGE patterns found in this outbreak, and we were able to find Campylobacter in milk that was sampled from the dairy, as well as cases from 2 facilities. We did find Campylobacter in a dairy worker at the prison facility that housed the dairy. We had a slightly different pattern in another case at a different facility, and then we had yet another pattern in cases from 2 other facilities. So it was kind of a mixture of PFGE patterns, but that's not uncommon for Campylobacter. And when you have kind of these large outbreaks, especially with a product like milk, and we, as demonstrated in our epi curve, we did have some type of continual contamination because the milk was consumed over several incubation periods for Campylobacter. We did do some food testing. The turkey that we collected did come back negative. We did find some illicit burritos in a cell of a case that we were able to collect, and those were negative. The milk did come back positive. Swabs from the milk equipment in the dairy were negative, and stool specimens from several ill staff members were negative. The control measures we implemented in this outbreak, including isolating cases and other ill persons until their symptoms had resolved. We recommended increased cleaning and hand washing. Ill food handlers were excluded from kitchen duty and submitted specimens. If those specimens were positive, we did require them to take antibiotics and had repeat testing until they had 2 consecutive negative stool tests. We had fact sheets that were distributed to all incarcerated individuals and staff. The prison system did halt unnecessary movement of incarcerated individuals in the hopes of not spreading the infection from one facility to another through potential person-to-person transmission. And then we had our environmental health partners review the pasteurization process, and we found that the heat and the time records of the pasteurization equipment were all within normal limits. There were no mechanical breakdowns. This dairy has cows on sites as well as the milk plant, and none of the cows had mastitis. There was no ill workers discovered that preceded the outbreak. We did find that there was a shared break room between the dairy workers, so those in the milk plant and those workers who worked with the cows. So that was a possible place where, just people wearing shoes and clothing and such, where there could maybe be some cross-contamination across people, where the dairy workers could have been exposed to feces or other contamination from the cows. So our conclusion in this outbreak is that these infections were caused by pasteurized milk. we did find that the 5-gallon bags that were filled with milk that were implicated in this outbreak, it was a manual process to fill those bags. The workers were wearing gloves, but it did require them to screw on and screw off different containers and caps and connect the hoses to fill the bags. So there is a possibility if someone's hands were not clean that they could have contaminated the milk bags that way. Also, the filled bags were placed on crates and stacked on the floor and then moved to a pallet. So there could be some environmental contamination that could have occurred. And again, production and shipping delays varied between affected facilities, indicating that milk was likely contaminated over several days. So that was the Campylobacter outbreak. And just kind of as a postscript, we did have another outbreak associated with this prison dairy back in 2010, which is an outbreak of E. coli, shigatoxin producing E. coli 0111. And this one is a little bit different, where we believe that there was environmental contamination from the dairy cattle that got into the cattle workers. The cattle workers are incarcerated individuals, got into their shoes, clothing, lunch boxes, and other gears. And then that material is brought back into the prison setting. And we had some workers become ill, but also spread the illness to others in the prison setting. In this particular outbreak, we were able to test the dairy cattle and did find the same strain of STEC 0111, which was indistinguishable to the human cases by PFGE. And there is an MMWR article on this outbreak. And this is kind of more of an occupational exposure that resulted in an outbreak in the prison setting. So if you're interested in looking that up, the MMWR is a pretty good summary of that outbreak. And that is it for me. Thank you.
Thank you, Nicole. Again, that was also a very interesting outbreak that you shared. And yeah, and so next I will go on to our next presenter, which is Dr. Justine Hutchinson. After training in environmental epidemiology with the California Epidemiologic Investigation Service, Dr. Hutchinson joined California Correctional Health Care Services as an epidemiologist in 2016. In addition to investigating outbreaks, she has led the TB surveillance program, helped implement wastewater-based epidemiology at 12 prisons, and evaluated health outcomes of a statewide substance use disorder treatment program. Again, just a reminder, if you have any questions, please go ahead and post it in the Q&A box, and then we will try to get to them at the end of the presentations.
Okay, thank you. So today I'm going to be talking about a salmonellosis outbreak at a California state prison that was linked to a ground meat product, and this happened back in 2016. So salmonellosis is a common bacterial foodborne illness. The characteristic symptoms are diarrhea, fever, abdominal cramps, and vomiting. Severe illness and death are more likely to occur among the elderly, infants, and persons who are immunocompromised. The incubation period is typically 12 to 72 hours, but can be longer, and illness typically lasts 4 to 7 days. Okay, so sources of Salmonella bacteria include people who are infected, especially food handlers, poultry eggs and ground meat products, contact with birds, reptiles, and amphibians, nuts, and fresh produce. Salmonella contamination of food can occur before harvest, during processing, or during food preparation. So for our outbreak, on April 28th, 2016, healthcare staff at a prison in the Central Valley of California identified a cluster of 62 patients with GI illness. Initially, a norovirus outbreak was suspected. However, all clinical testing for norovirus was negative, and 2 patients subsequently tested positive for salmonella. Both of these patients had salmonella serotype I4512I- infections with matching PFGE patterns, pulse field gel electrophoresis. We therefore investigated this as an outbreak of salmonellosis. So to identify probable salmonellosis, we used a case definition of diarrhea with abdominal cramps, with onset on or after April 1st. And 35 patients had illnesses that met this case definition. So this is the epidemic curve showing the onset dates for the outbreak. And this pattern is not consistent with the point source outbreak. It spans multiple incubation periods. Note that the outbreak was not detected until April 28th, which was more than 3 weeks after the first onset date. And delayed detection definitely complicated this investigation. Most of the patients who came forward with symptoms lived in Yard A. So foodborne outbreaks in the community are commonly investigated using a case control study design. However, in an institutional setting like a prison where food exposures are shared by a high proportion of the population, a cohort study might be necessary to achieve the power required to identify an association of illness with a commonly consumed food. Based on our power calculations, we chose to conduct a cohort study of 400 prison residents. For feasibility, we conducted our cohort study in 3 of the housing units in Yard A, which had the highest attack rate. Based on our hypothesis generating interviews and with 6 case patients and examination of prison menus, we selected for our questionnaire 23 different foods from the prison kitchen and canteen. The canteen is a place where inmates can purchase food items such as chips, canned goods, and summer sausage. We also asked about eating from spreads. So spreads are meals that are prepared by inmates in their cells or in common areas of the yard. These meals supplement or replace meals from the prison kitchen. At this outbreak prison, a typical spread was described to us as being made from dried ramen noodles with ingredients that are saved from sack lunches, such as bologna, and items purchased from the canteen, such as the sausage. Prison staff were concerned that spreads were exposing inmates to pathogens through unsafe food storage and handling. We asked patients with diarrhea about the foods they likely ate during the week before their symptom onset, and those without diarrhea about foods that they likely ate in the month of April. We offered interviews to 412 residents and 89% agreed to participate. So we completed 371 interviews. The attack rate for GI illness that met the case definition was 12%, and an additional 8% of those surveyed had GI illness that did not meet the case definition. 80% had no GI illness. In our main analysis, we compared those who met the case definition to those with no GI illness. In this univariate analysis, only one item was positively associated with illness and statistically significant, and that was dishes made with ground meat from the prison kitchen. Interestingly, eating from spreads and eating sausage from the canteen were protective. The table at the bottom shows the adjusted odds ratios from the multivariate conditional logistic regression. The dishes with ground meat remained positively associated with illness in the multivariate analysis. So the ground meat product was initially described to us as ground beef, but it turned out it was actually a composite product of 34% beef, 33% mechanically separated chicken, and 33% textured vegetable protein. It was made from these components at a central processing facility for the state and distributed to prisons throughout the state. For those who don't know, mechanically separated chicken is a pasty meat product that's created by forcing unstripped bones under high pressure through a type of sieve to create an edible meat tissue. To separate edible meat tissue, including tendons and muscle fiber from the bones. It's an inexpensive form of chicken. So while we were doing the epidemiological study, the state health department also started the environmental investigation. They started by collecting and testing samples of items and ingredients for salmonella. So they were able to obtain entrees that were cooked in the prison kitchen from ground meat or chicken pieces from early May, May 2nd through May 5th. These items were negative. They also tested pre-cooked hot dogs from the prison kitchen. Those were negative. They tested the raw chicken pieces. Those were negative. And then they tested the raw ground meat product, and it tested positive for salmonella. And in fact, from one lot collected at the Outbreak prison, they tested 10 subsamples, and those were all positive. And then they got 7 more lots from the processing facility, and those were all positive. And in total, there were 75 isolates identified. So they went on to characterize a subset of these 75 isolates. They didn't go forward with all of them, but what they found was that overall, the findings were consistent with the ground meat product being heavily contaminated with salmonella. Among the isolates that they characterized, they found serotypes Typhimurium, Seftonburg, Kentucky, Heidelberg, Schwarzengrind, Enteritidis, S. I4512D- and Infantis. There were 15 distinct pulse field gel electrophoresis patterns. None of the isolates from the product matched the isolates from the case patients. However, we note that the lots that were tested were not actually the ones that would have been eaten by the patients prior to their illnesses, because the illness onsets were of the 2 confirmed case patients were in early April. So salmonella is killed by cooking, and therefore the outbreak could have been due to inadequate heating or cross-contamination after cooking. We examined the kitchen records from the month of April, and adequate heating was documented for dishes containing the ground meat product. The state health department inspected the cooking of the ground beef product in the prison kitchen, and they found that cooking and food handling practices were generally good. Cooking and temperature monitoring were adequate, and no cross-contamination was observed. So that kind of rules those out as the primary factors. Therefore, we hypothesized that the level of contamination of the product was so high that the food remained contaminated despite cooking. The microbiological findings were consistent with a high level of contamination, and we concluded that the high level of contamination was indeed a factor. Next, we needed to identify the source of the salmonella in the product. The state health department tested the soy component, and they found no salmonella. The USDA, who had jurisdiction over the mechanically separated chicken and beef components, chose not to test them. So we were left to determine the most likely source by indirect means. Mechanically separated chicken in the US is much more likely than ground beef to be contaminated with salmonella. But actually, the most damning evidence for the mechanically separated chicken comes from the salmonella serotypes that were found in the ground meat product. So none of the 7 most common serotypes from ground beef were found in the ground meat product, while all of the 5 most common serotypes that are found in ground chicken were isolated from the ground meat product. So therefore, we concluded that the most likely source was the mechanically separated chicken. So in summary, a raw ground meat product used at state prisons was associated with an outbreak of salmonellosis. The ground meat product was heavily contaminated with salmonella. The outbreak occurred despite generally good cooking and food handling practices, and mechanically separated chicken was the likely source. In response to the findings of the investigation, the composite product that was already out at institutions was impounded and destroyed, and that was 77,000 pounds. The composite product that was still being stored at the processing facility was also impounded and destroyed. And the product, there was a policy change. The product was reformulated with white trim chicken replacing mechanically separated chicken. Oop. Thank you to our collaborators at the State Health Department and the U.S. Department of Agriculture, and check out our paper about this outbreak. Thank you.
Thank you, Dean. Thanks for sharing details of the MSC outbreak. And now I'd like to hand it over to our last presenter, Kim Lucas. Kim has served as an epidemiologist with the California Correctional Healthcare Services since 2010, and she has implemented and coordinated several case surveillance programs, including one for Valley Fever, and supported foodborne legionellosis and COVID outbreak responses in the California state prison system. And Kim's current focus is on evaluating health outcomes of the substance use disorder treatment and hepatitis C programs.
Hello, thank you very much. Today I'll be talking about a salmonellosis outbreak at Calipatria State Prison, which is in the California Department of Corrections and Rehabilitation, that occurred back in 2019. And just by way of an outline, Calipatria experienced a really large salmonellosis outbreak that started in October of 2019. We at headquarters had received a report of a large increase in GI illness that occurred over the weekend. And today I'll be going over some of the response actions, which are shown in blue, including patient testing and public health nurse surveillance for cases. And then also some of the confirmation milestones in the outbreak, including stool testing and food testing. So Calipatria is divided into 4 facilities or yards, A, B, C, and D. And these are yards that are mostly separated. There's very little, if any, commingling between the yards. And each yard has a satellite kitchen to the main central kitchen. And at the time of the outbreak, there were about 3,500 residents, an average of close to 900 per yard. And each yard has 5 housing units, which have 2-person cells and about 175 people in each housing unit. So this is the epi curve. GI illnesses were reported over the weekend, again, October 11 to 13. And in total, there were 110 ill and 5 patients were hospitalized. There were no deaths. There were ill patients in all 4 facilities. Altogether, there were 19 patient stools collected between October 13 and 21, and 10 of those were positive in patients whose symptom onset dates were October 11 to 13. So again, over that weekend. And we calculated the most likely exposure period as being the week before the weekend, Monday through Friday, the 7th through the 10th, or sorry, the Tuesday, the 7th through the 10th. There were 7 ill culinary workers, including 1 worker in the main kitchen in the sandwich room, but their onset was October 15th. And there were several dining hall workers who were also ill, and their onsets were October 11 to 14. As I mentioned, there were 10 salmonella culture positive specimens, and those were collected from patients with onsets over the weekend. And 9 of these were subtype 3A, 43Z, 4Z, 2, 3. And so looking at the Salmonella enterica subtypes, subtype 1 enterica accounts for 99% of human salmonellosis cases, and it's principally related to livestock, warm-blooded animals. And then we have subspecies 2 through 4, which are principally related with cold-blooded animals. And the serotype identified in this outbreak was actually very rare. It's only been isolated in California in 2009, 2011, and 2012. And it has not been associated with any other outbreaks. Our California Department of Public Health Food and Drug Branch tested some foods that were selected from meals that were served over the weekend, shown here. However, none tested positive for salmonella, and these meals were served after the most likely exposure period of October 7 to 10. From the health department inspection of the facilities at Calipatria, there weren't any, issues found with food handling or preparation. However, there were some other findings that were noted, including inadequate hand washing stations and hot water temperature being too low at the vegetable prep sink, and some couple other issues found, shown here. So to determine the most likely source of the outbreak, we conducted a case control study comparing the food exposures of the ill and well patients in Facility D. And we picked Facility D because that's where the majority of ill patients were, and for logistical reasons. And we developed a questionnaire to collect the symptom onset dates, specific symptoms, and food histories during October 7 to 11. You can see here the menus were quite extensive. We picked 55 food items from the kitchen, which would be breakfast and dinner, and then from boxed lunches, and then any foods eaten from other sources, such as the canteen. And we consulted with the California Department of Public Health Infectious Disease Branch to narrow down this list of foods. So we offered the questionnaire to 633 residents who had been in Facility D since the beginning of October, and 90% accepted, and 531 who we confirmed were present throughout October 7 to 11 were administered the questionnaire. So included in the case control study were 55 ill patients, including 2 that were had salmonella positive stools, and these patients had diarrhea and a symptom onset date on or after October 7th. And then the controls were 329 well patients who had no diarrhea, vomiting, or fever reported. And so these are the numbers included after we excluded those that had incomplete symptom or food history information. And the questionnaire was conducted over 2 days, and we had a team set up in each of the 5 housing units, which included, an epidemiologist or a headquarters public health nurse, and then also public health and other nursing staff from Calipatria. And we trained them to administer the questionnaire. And so just looking at the results overall from the breakfast and lunch foods eaten, people who were ill were no more likely to report eating any of these foods. However, we did find significant results with any of the fresh salads on Monday through Thursday throughout the week. So was there salmonella in all 4 salads? This is really unlikely because the epi curve suggests a point source and is not consistent with ongoing exposure. So the most likely explanation is that one salad was the source. Eating any salad was strongly associated with eating all of the salads, as shown here. So getting back to the questionnaire, looking at the odds ratios for the implicated foods, people who were ill were more likely to have eaten the salads, as I mentioned, on any one of the dinners. But Wednesday and Thursday, based on the most likely exposure period, it seems like Wednesday or Thursday salads were most likely the source. And respondents who ate any food from a quarterly package, which is food that they are allowed to receive in the mail, had a protective effect. So we traveled again to Calipatria following the outbreak for an action item site visit. And as a result of that, we have really strongly emphasized retaining food trays for testing for at least 72 hours, especially when illnesses occur over the weekend. In this case, in this outbreak, all of the food that we had available to test was over the weekend and not actually during the most likely exposure period. There were issues that were found by the health department at the facility, and all of those were corrected. We also worked with Calipatria to kind of run through the checklist and improve local operating procedures for GI illness response. And then we also worked on improvements for our statewide CCHCS nursing protocols and provide continuous education for public health and infection control nurses in the field. So in summary, Calipatria experienced a very large salmonellosis outbreak, and this was a point source outbreak. Although we were unable to identify a single salad as the source, it seemed most likely to be the Wednesday or Thursday salad. There was no conclusive evidence of issues with food preparation or mishandling, and Calipatria has not had a subsequent foodborne outbreak since 2019. So I just wanted to say thank you to all of our partners who worked on this outbreak investigation and response, from Calipatria, from CDPH, and also from the local county, and here at headquarters, our public health nursing services. Thank you.
Thanks, Kim, for sharing your knowledge and experience with the produce outbreak investigation and some of the challenges. We are at our final minute, so if our presenters have time to stay on to answer any remaining questions, that would be great. But if not, it's fine. And if you could, I just wanted to thank all of our speakers today for taking time to share their knowledge, and wanted to say there will be a very short feedback form that will pop up as you exit the meeting. We'd be super appreciative if you could please fill it out. It's completely anonymous, and we'll take only a few minutes to complete. And our next webinar will be held on November 20th, and the focus of that one is on high-risk foods in correctional facilities. You can register for it at the link posted in the chat. And we also put a link to the Integrated Food Safety COE website in case you would if you would like to learn more about what we do, as well as email addresses for all of today's presenters if you have any specific questions for them. And I want to thank everyone for joining today's webinar. I hope that you can make our next one next month. Again, you can register through the link in the chat. And yeah, if anyone has time to stay on, we can go over some of the Q&A questions. I think a lot of them were answered in a chat, but I think this one was a blanket one for all of our presenters today. And just from Samantha Spencer, how easy or hard was it to work with and get buy-in with the prison systems to allow your teams to follow up on an outbreak or interview cases? And specifically, what steps did you take to build those relationships to allow for your teams to interview cases now or in the future? I don't know if anyone has any tips or suggestions for that.
Well, so this is Justine Hutchinson. Kim and I are both with the prison healthcare system, so we don't need buy-in from the system. Although we do need to work with our custody partners. And sometimes you get useful information from the custody side about, like, different dynamics going on in the prison, and that might help you choose to do your survey in a way that runs more smoothly and you get a higher response rate. We also it's important to get buy-in from the residents of the prison as well. And one way that we do that is that we use I think they've changed the names, but back in 2016, when we were doing our our investigation, it was called the Inmate Advisory Council. So it's a kind of a group of residents that are representing the population, but they can also communicate things back to the population. So, we make them we make sure that everybody has the message that we're investigating this issue to help them, and it hopefully sets the stage for people to be forthcoming about their symptoms and their exposures.
Thanks, Justine. And I did see Jolie did type in a response, and I can just read it. So for the botulism outbreak, during the first botulism outbreak, it was more difficult, but after a second outbreak, the wardens were very open to having public health come into the prison and provided Arizona easy access to correctional officers and inmates. And after this outbreak, they set up some routine meetings with correctional facilities, the wardens and healthcare personnel, and then held some tabletop exercises with correctional facility staff. So it sounds like just having a repeat of an outbreak made the correctional officers a little bit more open to working with you, Jolie. I don't know if you have anything else to add to that.
Yeah, especially for that prison, I think they recognize the severity as well for botulism. It's more difficult for us to get in after that first outbreak, but right after the second outbreak, they were like, "Please come and help us." And so we were able to establish that relationship and work with the wardens and set up more routine meetings with all correctional facilities. We also assigned a staff person to be sort of the point of contact for correctional facilities. I think it was helpful for us in Arizona. So we had somebody routinely sort of in contact with the correctional facilities as well.
I would say in Colorado, that strategy has been successful for us as well. We've had a dedicated epidemiologist kind of serving as a liaison with our Department of Corrections for many, many years, and that at least we have those relationships kind of established when an outbreak or a case of disease pops up, where we know who to call and have those relationships made.
Thank you. And so how they establish some of their partnerships and relationships with facilities. And then we'll also have Minnesota come on and talk about some topic that you're specifically interested in. Please join us for that webinar. And I think just going over the questions in the Q&A. And that's a great point, Orion. Helping to build that trust and know who to reach out when there is an issue is really important. So really good point. But I think that is all of our questions for today. If anyone thinks of anything, please feel free to reach out. And I want to thank everyone again for taking the time to join our webinar today, and hope to see you on our next one.